The first group of numbers we're going to look at are the primes, and they aren't predictable. If we take the number 17, and 17 is there because no number below it, up to 16, will divide into it without leaving a remainder. So let's test that. Okay, there are all the numbers below 17, excluding 1, which is our counting base, not a prime number. We can immediately cross out all numbers which are above half of 17, because they will go in once, leaving either a large or small remainder. So if we start from the bottom now, 2 won't go into 17 because it's an even number going into an odd and there'll be a remainder of 1. That will knock out any other even numbers. We don't even have to bother to try thinking about those. 3 won't go in, the nearest being 15 with a remainder 2. 5 won't go in, 15's the nearest, again with a remainder 2. 7 won't go in, the nearest being 14 with a remainder of 3. Therefore, we declare 17 as a prime. So it's good to know what numbers are primes and what aren't primes. Okay, let's move on to the squares. So if I take 1, 2, 3, 4, 5, 6, 7 and square each of the results, there they are set before you. Spotting 81 in the question almost certainly means you're going to be square rooting it back to 9 in the process of finding that answer. I suppose the other number to mention is 49. It looks like it should be a prime, but it's just 7 squared. So again, it's worth knowing that sequence. The same thing applies to the cubes. To spot that 8 is 2 cubed and 27 is 3 cubed and so on is very useful and can certainly aid the solution of a complex question. And our last list here are the powers of 2. So this is just doubling 2 times 2 times 2 to generate your next number. When we come to look at powers, the number I always remember is that 32 is equal to 2 to the power 5. That's 2 times 2 times 2 times 2 times 2. Okay, let's move on to those rules and tips. So the first of the rules involves the multiplication of 2 negative numbers. So if I take negative 4 and multiply it by negative 3, I get positive 12. I tend to overuse brackets, and it's not a bad practice to wrap your negative numbers in a bracket so that you don't get confused and start subtracting numbers when you should be multiplying by a negative number. Our next rule is that squared numbers are always positive. 4 times 4, positive, 16. No question of a negative there. But if we multiply negative 4 by itself, we've got the same thing. Negative times negative equals a positive answer. So this is positive 16, the same answer that we got before. Now, the reverse of that rule, that squared numbers always produce positive answers, means that when we go backwards, we've got to be quite careful. Because if we take 16 and want to do the square root of 16, well, we know that 4 squared will generate it, or negative 4 squared. So when we take the square root of 16, we have to write that the answer could be plus or minus 4. And that's how you write it, with the plus sign above that negative sign. Plus or minus 4. So that line that's highlighted there is a useful technique. So if I just write down 12, what numbers below 12 go into it without leaving a remainder? Well, 2 will go into it. 3 will go into it 4 times. 4 will go into it 3 times. 5 doesn't work. 6 will go into it twice, and everything else above 6 can't go in because we're above halfway. So combinations of these 4 numbers can represent 12. 2 times 6 equals 12. 3 times 4 equals 12. And 3 times 2 times 2 also equals 12. So what I'm trying to encourage you to do is to not see 12 just as 12, as 2 above 10 or something like that, but see it as a multiplication of its prime factors. It means that when you come to simplify a problem, you'll know that you may be able to get rid of a factor of 3 all the way through an equation, or top and bottom on a fraction, just because you know that 3 is a factor of both of those numbers. It's a useful technique. And lastly, a couple of simple facts, but worth writing down, that if a number is even, any number is even, a factor of 2 can be taken out. So if I take any even number, let's say 56, I can write that as 28 multiplied by 2. Now that could be useful at any time in a calculation to simplify things and bring numbers down in value and produce a solution to the question. And lastly, if a number ends in a 5 or a 0, then it's divisible by 5. And there are 2 examples there. There's 60 equaling 12 times 5, and 135, which equals 27 times 5. So again, if your number ends in a 0 or a 5, then a 5 can be brought out as a factor. So if you can spot that a number belongs to one of the families we've looked at, or indeed that it can be broken down into its prime factors, this will help enormously in many questions, and it'll enable you to cancel large numbers down to much smaller numbers and find a solution to that question much more easily.